In this lesson, we're going to dive deep into the more complex or advanced querying techniques and the keywords that go along with those. Don't worry, I'm going to walk you through step by step. I'm fairly certain you'll get these things. I'm going to try to break them down as simply as possible. So over here we have SSMS. And again, I'll start a new query. And I'll put all my lines in there so I have some room to play around. I never start on line 1 because if I have, let's just start on line 1 for a minute. So if I have like this, it's a little difficult to get above it to come down. I had to go up. And the same is true if I start at the end. I have to come from the top down, but I can't come from the bottom up as easy. And so I never like to play against the boundaries. And that's just a personal thing. It's nothing that you have to do or emulate if you don't want to. It's just what I found is easiest for me. Okay, so the first thing I want to cover is the idea of grouping data. Now, I've gone ahead, let me show you. Select star from dbo.workdone. If we run that, notice I've added a few extra records. Okay, it's just we have some more data in there to play with because grouping, it shows it off better if you have more rows. So let's look at what grouping does. So I'm going to group by the customer for work done. So I'm going to say, okay, say it's the end of the week or the end of the month, we're going to bill each customer for the total number of hours. Let's pretend like there's not a different hourly rate for each person. So how we do that? Well, first we have to join up to get customer. So we start by making this W, and we'll do W.star, just so it's clean, and then say inner join, and we can't join customers yet because we don't have a customer ID in this table. We have a location ID and a job ID. Let's join on the job ID. So dbo.jobs, that's J, on w.jobid equals j.id. Okay, so we've joined now the jobs table to the work done. Inner join mean the two have to have the same entries in order to match, which we know is going to happen. And I can inner join again, dbo.customers, C on j.customer ID equals c.id. So see what I've done is I've chained this. I got a work done table, and I linked that to the job table by the IDs. And then I linked in the customer ID to the job table. So now it's work done, linked to job, linked to customer. Which means now I could say c.company name. If I run all of that, I get all the job information in these columns, but then here I also have company name. Notice the company name is Acme, Acme, ABC, Acme, ABC, Acme, Acme. So we have 7 different entries for work done for 2 different companies. So we're going to say, okay, well, I want a report that just says the company name and the total number of hours that they've worked or been worked for them. So to make things easier, let's count ABCs. So this row, which is 9 hours worked, and then we have this row right here, which is 2 hours worked. It's kind of hard to see when I zoom in like that. So there we go. 2 hours worked, 9 hours worked. So the combined you'd want to see for ABC Incorporated is 11 total hours worked. How do we see that? Well, that's where we do a group by. So we're going to say, let's group by the company name, and then I want to see a sum of the work done dot hours worked. And we'll call that total work. All right, so now we have the company name and then this method right here, or function called sum. And what sum does is it takes a column and it adds all of those entries up in the group. Now, how are we going to group? We're going to group by company name. We have to tell the query that. So therefore, down at the very bottom here, we're going to say group by c.company name. In fact, if I didn't do that, let's just show us for a minute. If I run this, it doesn't work. I get an error message. But I'm going to say, okay, group by the company name. So it's going to have two groups, ABC and Acme. And let's take let's take ABC for a minute because we know that ABC has an entry for 9 hours and one for 2 hours. So I'm saying, okay, that first set is ABC and it has two entries, 9 and 2. Those are the hours worked. So give me the sum of the hours worked, 9 and 2. So it's going to say that's 11. Let's check this out. There we go. 11 hours total worked for ABC Incorporated and 28 hours for Acme. Now, what if we said, let's group by not only the company name, but the employee who did the work? Well, let's do that. So we need to add first in the employee. So inner join dbo.employees e on w for work done .employee ID, the guy who did the work or girl, equals e.id. So now we can say e.first name. Let's just do first name for now. And down here I have to include that in my group by statement, e.first name. So now we're saying not only by the company, but then inside each company by the person who did the work. So now see we have 5 records. And notice that the company name is Acme, then ABC, then Acme, then ABC, then Acme. Let's go ahead and order this. Order by company name. And run again. So now we have the 2 ABC Incorporated. So why isn't this one just ABC Incorporated? Well, because Sue did work for ABC Incorporated and so did Tim. Therefore, since we're grouping by both the company name and the employee's first name, we're saying that Sue did a total of 9 hours. Tim did a total of 2 hours. For Acme, Joe did a total of 14, Sue did a total of 4, and Tim did a total of 10. So that's group by. And it can get a lot more complex if you want it to, but it really boils down to the same thing. We're doing groupings. These are the things that make each record or each row in this results table unique. So company name, if it's just company name, then you only have Acme once and only have ABC Incorporated once. But this says the unique part is company name and e.first name. So Acme Incorporated Sue, ABC Incorporated Sue, ABC Incorporated Tim. Now for Acme, I believe that Joe actually has 2 entries, and those are then summed together. Everybody else just had 1, therefore they just get shown up there. So that's group by. Now, there can be some more complexities here that we can add to it to not just make things more complex, but make things more powerful. And one of those is the having statement. And in fact, having is kind of like the where statement, but when a group by, you can have both where and having, and they're different. So if I said, well, let's first look at the select star from dbo.workdone. let's look at these entries here. And I know that, oh, real quick, let's take a peek. I believe that one of these guys has done some work. Joe Smith, I believe, too. I believe Joe has done work for more than one company. There we go. So he built the first floor for location or job number 2, and then he added the plumbing for, he trimmed the entire property. So those 2 things he did for job number 2 and job number 3, both of which are for Acme. Okay, so we know that we have 2 entries for him. So now that we know that, I can demonstrate the difference between a where and a having. So above the group by is where goes. Now where acts upon this query before it's grouped. Okay, so I could say where, and let's say W dot, and let's go with ID. We're just going to take out this entry right here, the 10 hours he did for this job number 3. So let's take out ID number 8. W.ID equals 8. And of course, this is a contrived example, but I want to show you what this does. So let's run this again. And now I've done the exact opposite of what I wanted to do. Surprise! So I said where ID equals 8. What I meant to say was where ID does not equal 8. Since I said ID equals 8, we only have one record. Therefore, we only have one company, one first name, and one total hours worked. How about we say not equal? And there we go. We still have 5 entries, but now look, Joe only has 4 hours. And if we comment out this entry right here, the where, and show it again, Joe has 14 hours because that's the one entry we took out. Now you may not have caught it right there, but let me highlight what I just did. I wanted to show everything but ID number 8. So I couldn't say equals. That's actually the opposite of what I wanted. I want to say not equals. If you are familiar with programming, C# or a lot of different languages, they use this character right here, the exclamation point, which is also known as the bang character usually. This indicates not. So where the workdone.id does not equal 8. So that's just a little more rounding out of your skills there. You now have the ability to say not. You could also say greater than or less than. And that would work too. So that would look something like this. And that too would do the same thing. It's up to you which one you want to do, which one you prefer. Okay, so now I've limited with a where clause, and that pulled out that one record if I wanted to. But everything else works the same way. But now let's add a having statement. And I add it after my group by because having works after the grouping is done. So where works before you group. Having works after you group. So what can I do with this? Well, I could say sum of W dot hours worked is greater than, let's say, 5. Now notice, before I run this, this is my current result set. Hours worked is 9, 2, 4, 4, and 10. Now I'm saying the sum of hours worked has to be greater than 5. If I run this, I get just the 9 and the 10 record. Because what I've said is, after you group by, I want to look at the sum column and see if it's greater than 5. Now, if I add back in, if I take out this where clause here, which is limiting Joe's hours, and I run again, now Joe shows up because Joe has 14 hours, not just 4. All right, so the where clause happens before you do grouping. The having statement happens afterwards. Now, the other thing you might be wondering here is, can I do something besides sum? And of course you can. There are a number of different things you can do. Here's the important ones, or the most common ones. Count. Count will give you the number of records in each set. So I could do this like so. I could say count, and here's a little trick, count of 1 as number of entries. And if I run that, number of entries is 1, 2, and 2. Now, why did I say count of 1 and not count of something? Well, because all we're doing is counting the number of rows. We don't really care which item we're counting. It's actually more efficient to put just 1 in there than it is to put something else. Used to be, you'd see a lot of times count of star. So star would be in this box. That too works, but it's actually less efficient. So now SQL's pretty intelligent, and usually they optimize these things. So it could be that it's the same now, but I do know that this is a highly efficient way of doing things. Just count of 1. Okay, don't put a column in there. Don't put anything else. Just put 1 and leave it at that. So now we know how many entries are in each set. So that's count. We've seen sum. We also have a min and a max. That's saying in this set, which one is the minimum, which one's the maximum. I can show you that in just a minute. Let me go ahead and give you some more working room on our query. So it's getting a little bit larger. And we will say min of w.hours worked as minimum. And if you want to, we can also do max of w.hours worked as maximum. Now, I'm using the hours worked column a lot. Don't think that you're locked into that column because of some reason. You're not. You can use any of the columns if you want to, but that's the one that works best for our example. In the real world, you might have 2 or 3 columns that you want to work on. And obviously, you probably don't want to have all of these every time, but this is just a good demo for you. Okay, so let's run this again. And now you can see that for a lot of these, okay, for one entry right here, the minimum and the maximum still 9 because that's the only entry they have. But the minimum entry here is 4 and the maximum is 10. Only 2 entries, so you'll have one as min and one's max, and they combine for the sum right there. And again, 3 and 7, total is 10. If you had 3 entries in one of these, you wouldn't see these 2 add to be this because you'd be missing one. All right, so you have the sum, count, min, max. The last major one is average. All right, let me run this again. And I have to spell it right, not work as, worked. And there we see that the average for Joe's Acme work is 7 hours. The average for Tim's Acme work is 5 hours. Looks like Tim's slacking. So that's your different values here. And notice, even though I'm adding all of these, I don't have to put anything in my group by list because I'm not grouping by anything different. I'm simply saying, give me some statistics about each set. Okay, and again, if I were to take off the first name from the select and from the group by, so now I'm just grouping by company name, it changes some of our information. For example, we only have 2 records now, Acme and ABC, and our minimum is 2 here, our maximum is 9, for an average of 5 and total of 11. And again, that adds together, but down here, look at minimum is 3, maximum is 10. That doesn't add to 28, obviously, because we have 5 entries, not just 2. And there's the average of 5. Is the union keyword, or possibly union all. So the union, what it does is it takes 2 different select statements and it appends them. Okay? So this is different than grouping by or joining them because it's not a join, it's just taking 2 separate statements and connecting them as if the first set of 4 statements, say, would then be added to the second set of 5 statements. You have 9 statements. Let me just demo this real quick just so you can see it. This is going to be a little bit of a nonsensical demo because we only have 5 tables and this doesn't make sense really in our context, but I think you'll get the idea of what it does. So if I said select first name, last name from dbo.employees. Okay, so there's my employee list. And notice Bugs Bunny is now added as an employee. And we'll get to why in just a minute. I can say union all select first name, last name from dbo.employees. Now, what this is going to do is take this set and add it to the bottom of this set's results. And since I said union all, which if you can get away with it, always do union all versus union. Union all says, I don't care if there's duplicate records. Just add them together. So notice I have 4 rows here. If I run this statement now, I have 8 rows. Because what it said was just combine those 2 lists. So I have Tim, Joe, Sue, Bugs, Tim, Joe, Sue, Bugs. If I had said union instead of union all, and I run this, I only get 4 records because union says don't allow duplicates. And since I'm doing this very nonsensical, select the same list twice, union just gives me the 1 set of results, essentially. Now, that doesn't make a terrible lot of sense because you'd be wondering, why would I ever just join the same table together to itself? You probably wouldn't. But let's do this instead. Select, and I'm going to do star for a minute, from, I can never remember the exact name of things, dbo.customers. And I'll actually call that C. It just helps IntelliSense this way. C.company name as name, and C.email address, and I'll leave that as it is. So this right now just gives us a list of 3 companies and their email address, their primary email address. Let's do union all, select e.star from dbo.employees e. Instead of e.star, we'll do e.first name plus single quote space single quote plus e.last name as name e.email address. Now what have I done? Well, I've taken all of the company names and column name and their email address from customers. And I've taken the first name space last name from the employees and call it name and their email address from employees. And I've union all of them together. If I run this, I now have a list of 7 email addresses and the name that goes along with it. So XYZ Corp, hr@xyz.org, Tim Corey, tim@corey.com, and so on and so forth. But notice, and this is why I added bugs. Acme Inc., the email address is bugs@acme.org. Bugs Bunny, the email address is bugs@acme.org. Now you'd say, why would they ever have an employee whose email address is also one of your customers' email addresses? Well, say it's a small company and, Tim does work for, or Bugs does work for us, but he also needs work from us, and so he's both a customer and an employee. Whatever. It doesn't really matter. The point is, we have this duplicate here, but union actually isn't going to fix it, because union says the entire row has to be the same. Still 7. So, what do we do to fix this? Well, first of all, let's do union all again. And this time we'll do just the email addresses. And if we run this, we see that we have bugs here and we have bugs here. We have 7 records. But if we do a union instead of a union all, we now have 6 records. What does this give us? Well, this gives us a mailing list. Now we could mail to all the email addresses we have in our system, whether they're customers or employees. So we've taken 2 separate tables with 2 separate pieces of or 2 separate types of information in those tables, and we said, you know what? You both have a common email address, and that's really all we need. We're going to try and email everybody we know that we're launching a product or whatever. And so we've taken the email addresses from one table, the email addresses from a different table, combined them together, and taken out the duplicates. And now we have a list of 6 email addresses. Pretty powerful stuff. Now, in the real world, when are you going to use this union versus union all? The answer is not that often. But keep it in the back of your mind that you can do this. Maybe write down a cheat sheet somewhere. For years, I had a cheat sheet along with me that would have all these different commands. Not necessarily descriptions and all the rest. I just had a list of commands because then if I saw it, I'd go, oh yeah, I could do it that way. So if I'm stuck on a query somewhere, I'd read through my list of commands and go, you know what? A union all might help here, or whatever. And so I would say put this in your list of those commands. And again, union all is much more efficient because it's not going through and looking for duplicates. So if you can get away with it, just do union all. In our previous example where we had the names, let's see if I can get back to that. Union all is fine because we don't have duplicates because the company name is not the employee name. So again, in the interest of making sure that you have a broad coverage of what you can do in SQL, I want to make sure I covered union all, but it's not something I use more than occasionally. All right, so that's union all and union. Let's talk about a few more before we get into our last major topic. So there is a couple more things I just want to mention, not necessarily a demo, but let's do select star from DBO dot work done. All right, and if we run that, we have our list. Now, one keyword, and I'm not going to demo necessarily the usefulness of it necessarily, but the keyword is distinct. All right, what distinct does, notice it didn't really change anything here. If I say select distinct star from, then what it will do is make sure there's no duplicate rows in here. And so if there are, it'll take them out. Now, we could kind of show us off by saying, let's just do, instead of star, we'll do job ID. Notice that there's a 1, a 2, and a 2, a 3, and a 3. Now there's another 1. So if I run select distinct job ID from dbo.workdone, I get 1, 2, and 3. Because those are the distinct entries. And if I had another comma here, just like with our union all, it will look at since we only have 7. Let's say I want the top 2 hours worked. Well, I can do order by hours worked descending. So now if I just did this, notice it's 10, 9, 7, 4, 4, 3, 2. Then I could say, give me just the top 2. And there they are. Now let's do top 3 for a minute. Oops, I'm sorry, top 4. All right, so I have 10, 9, 7, and 4. But if I did 5, notice these 2 4s here. How did I know which one to pick? Well, really it's kind of based on when it was in the database, because there's no more ordering besides hours worked. So let's change that. Let's be intentional about which one we pick. Let's pick the one that came first. Okay, so if the tie happens with the same number of hours, let's choose the one that the work was done first, which in this case is mowed the lawn. That was done on February 1st, while build the API was done February 2nd. So order by hours worked descending, date performed. And since we don't specify, it's ascending, meaning the first and then the second. Let's just demo this by doing the top 4. We should see mow the front lawn. And in fact, we do. Mow the front lawn is there, but build the API is not, because that happened next, on the next day. All right, so the top 4 or top 1,000, top 50, that can be used to give you, the winners, maybe the top 3. But also it can be used for things like limiting your returned rows so that you don't have a million records, literally, down here. That'd be a bad thing. Whenever you have a production database or a database with lots of records, I would suggest whenever you do something like this, where you have select star from, or that's the place I have it, I guess. But usually I grab things quick and I say select star from dbo.customers. And I just run that. Well, in a production environment and in even a development environment where it has a copy of your production data or something similar where you could have thousands and thousands of records, it's probably a good idea to select top 100. And ordering is not as important if you're just looking for information. I'm just looking for the kind of the structure of dbo.customers. I'm not looking for specific records. Select top 100 is great. So it can be a performance thing in your development as well as a benefit for you when it comes to making sure that you only get certain records. So that's the top X or top N. So top 4, top 100, top 1,000, whatever you want. And the last thing I want to cover in this lesson is a little bigger of a topic, just because we can get complex with my example here. But the foundation of it is that you can create a table in your query. So for example, we've seen how we do, just select star from dbo.customers. But instead of saying the table name, we could actually do something like this. You put it in parens and say select first name, last name from dbo.employees. We could call this, I don't know, E. So E dot. If I run this, notice I get just my first and last name, even though I said select star. But I didn't specify a table name here. I specified a query. That's a query. Well, that's because you can do this and call it a table. And your query will say, okay, that's a table. That's fine. And it will join it. It will do all the rest as long as you pass information through to join it on. Okay. In here, I didn't pass any IDs through, so there's nothing to join on. So therefore, it's almost useless. But let's look at a real world type example in this database that would make sense where you'd want to do that grouping. So I want to get the top worker for each customer. So the idea is I want to say who has done the most work for XYZ Corp, for ABC Incorporated, and for Acme. Who's done the most work for each of those? Well, you might go, oh man, it's a really complicated query. Not really if you know that you can do these dynamic queries and treat them like tables. So let's start by saying select star from customers C. And we'll just do C dot star. Okay. That's a simple, we have those 3 customers. Cool. But how do you find out the top performer? Well, in our select statement, and here's where it could blow your mind a little bit, we can also put a dynamic SQL statement. So I'm going to put comma, like I'm going to do in our column, but instead of another column, I'm going to put a select statement. And I'll do it on a new line. Select top 1 e dot first name plus single quote space single quote plus e dot last name from work done W inner join locations L on W dot location ID equals L dot ID. I'm going to go back and explain all this, make sure you catch it. But this is what we've already done before. Inner join on employees E on W dot employee ID equals E dot ID, where C dot ID equals L dot customer ID. Group by E dot first name, E dot last name. Order by the sum of W dot hours worked descending. Wow, is that complicated or what? Let's go back and look at it for a minute. Let's actually take this entire query out and look at it on its own. But in order to do that, I have to take out this where clause. Okay, because we're linking on the customer ID. So if we run this, we get Joe Smith. Because I said top 1. Now if I say top star, I can't do that, can I? It could be top 100. I'll just take the top. There we go. So that's telling me nothing really of importance. But what it's saying is select the first name space last name. So that's just the full name from the employee table, which is linked through locations, which is linked through work done. So that right there, if we didn't do the group by, there's all the entries for our work done table. So Tim did work, Sue did work, Joe did work, Tim did work, Sue did work, and Joe did work. So those are the work entries. So I said, okay, there's all of those, but I want you to group by their first and last name. That's cool. Okay, so now we know that we should only have the people who've done work. In this case, all of us have done work, except for Bugs. Bugs hasn't done any work. So now I've grouped by that, but I want to order by the sum of W dot hours worked descending. Now I could show this here. Let's copy this and put it up here just so you can see it. So Joe has done 14 hours, Sue has done 13, and Tim has done 12. So now I have grouped by the hours worked for each person overall, for all jobs. Which gives me, okay, I know that Joe is in first place with 14 hours, and so on. But I kind of took it to the next level by saying top 1. What that does is it gives me only the person who's done the most work, Joe. So Joe has done the most work out of all of us. He's done 14 hours worth of work. That's a ton. But then I took it one step further and I said, where company ID equals, actually this customer ID equals C.ID, which actually comes from our customers. So for each customer, give me who did the most work. And we run this, we can see that for ABC Incorporated, Sue did the most work. For Acme, Joe did the most work. And for XYZ Corporation, nobody worked. Which we know that. We have not seen anything for XYZ Corporation yet. So therefore, with no hours worked, no one has done anything for XYZ. All right, so that allows me to say, here's who's done the most work per company. And I did that by a subquery. Now, why did I say top one? Well, when you are using this statement right here, not as a table, but as a column entry, you can only return one row and one column. Anything more is a problem. Okay, so if I try to return two columns, let's just say I try to return sum of W dot hours worked. If I try this, it says right down here, only one expression can be specified in a select list. So I can't return two different columns. I also can't return two different rows. If I run this, again, it says subquery returned more than one value. This is not permitted. Okay, so I have to return just one value. And that makes sense because think of it as an Excel spreadsheet. You have one cell. Say it's a C3. It's the column is C, the row is 3. You have one cell. You can't put two different pieces of information there. You can't put two rows of information in there. You have one cell. So whenever you do a select statement like this, wrapped in parens, inside as a column, so it's in the columns because it's in the select, you can only have one cell's worth of information. Whereas if you have it as a table down here, you can return an entire table's worth of information. So these dynamic queries, essentially, dynamic tables that you're creating, can be used in a lot of different ways, really powerfully. It does get a little confusing at times just because you have to keep track of where everything is. But again, I'd get back to make sure you write down the order for your keywords. It's select, and then it's from, and then it's join, then it's where, group by, having if you have it, and then order by. Because then when you have all this text here that looks so confusing, you go, wait a minute. It's select and then from. And that's really all there is to it. And then inside of one of my columns, it's select, from, join, where, group by, and order by, which really isn't that intimidating. Okay, so maybe it's a little intimidating, but just because it's a lot of text. We've covered all these things, and really these are, I think, as small Lego bricks. And you're just putting together a big Lego creation, but it really comes down to just brick after brick after brick. So here we've put together quite a few bricks into a pretty large structure, but the reality is it's just small bricks added together. So that's dynamic SQL. So you can do a lot of fun stuff with it. You can have tons of these if you wanted to. Just be careful because it does make things look complex, and it's sometimes hard to figure out why you're doing what you're doing when you have all these. I would definitely encourage you to use your line returns carefully and to make sure that it's understandable what you're doing in these line returns. So for example, I didn't have everything pushed over to the left. That is confusing. Because I tabbed everything in, By the way, if you highlight all those rows and hit tab or shift tab, they move in or out one indent. So because these are all tabbed in one, it's easier to see that these all go together, whereas this row right here, row 5 and row 13, are on what's called the same level. These are part of the same specific query. Okay, this is a subquery that goes inside of this query. So tabs are your friend, use them. You might want to change, I haven't changed the defaults, I believe the default is actually the tab character. I would go in and change that to the space character and make it like 2 or 3 spaces. Because this right now is essentially 5 spaces, but it's 1 tab character. Not really great. It's just way too inefficient for space usage. So, with that being said, that's the advanced SQL lookups. That's advanced querying. So we've got the group by, we've got the unions, we've got dynamic tables. Those are the big ones. We also mentioned distinct and the top X or top N rows. So those are things to look for too. All right? Make sure to practice this. I'll have homework at the end of this. Make sure you do it. All right? See you in the next lesson.